photons and gravity. This is also a genius of Einstein. You know how we've heard about photons bending time and space? Like how time and space are bent and stuff? It all comes down to this one single quick thing. So, light is affected by gravity. If light was a wave, when it passes by a mass, it should just pass by it, or it should just pass through it. But it doesn't. Do you remember the gravitational formula for forces? F equals G m1 m2 over r squared. What does that say? If you have two masses in space, they are going to be attracted towards each other. Now, if light was just a wave passing by a sun, it should just pass by, maybe diffract a little. But what Einstein said was that it actually doesn't diffract, it actually gets attracted towards the sun as if it was a massive particle. Like it's not a massive particle, but a mass. How else do I call it? It had a mass. So this is another reason why we think photons have mass. Are we ready? And the derivation is so pretty and so cool and so surprising. Okay. What is the momentum? mv. So a photon mass can be written as hf over c squared. So how does a photon interact with a gravitational mass? What is a gravitational mass? A gravitational mass is like Earth or Sun or any other object that actually has a mass. So what Einstein's genius was that he said that a photon of frequency f interacts with an object as if it had a mass. Okay, so what is a common way that we interact with Earth? So if this is the surface of the Earth, and you have a ball here, and you're holding it up, and this is a height h, and you let go of it, what will happen? It will fall, right? We all know that. If the kinetic energy here is 0, and potential energy here is mgh, is the kinetic energy here 1/2 mv squared, and potential energy here 0 for a stone or a ball, and this is Earth. Is this going to be true? Where g is a gravitational pull, right? Acceleration due to gravity. May I write here potential energy initial plus kinetic energy initial equals potential energy final plus kinetic energy final? If I plug these values in here, will I get mgh equal 1/2 mv squared? Or will I get v equals 2gh? Keep this in mind. Now let's discuss if instead of a ball, we have a photon that is falling towards the Earth. All photons must have speeds c. What happens if a photon falls below the speed of light? It doesn't exist, right? It just disappears. It has to travel with the speed of light. Very good. It cannot go any faster. It cannot go any slower, right? It has to be at the speed of light. So a photon falling through height h, say the same height as our ball, will also have an increase in speed, correct? but it can't go any faster than the speed of light. So what does it do? It has to, right? There's MGH, it had MGH, it had Earth, it has to increase its speed, right? So how does it manifest itself? Because it can't go faster than the speed of light. So what it does is, it changes its frequency from F to F prime, where F is lower and F prime is higher. So it changes from F to F prime. So imagine if it was a red photon at the height h, it's going to be a blue photon by the time it reaches the surface. That's an over-exaggeration. It doesn't actually happen. The actual change in frequency is so tiny that we generally ignore it. So basically what we're saying is, as a photon falls, the change in frequency will be HF minus HF prime over C over C. But in general, H prime, the F prime is so significantly small that we generally write delta F equals HF over C. In our lab scale experiments. In lab scale experiments. So, may I copy what I did here? Again, I'm going to copy it. So instead of now my ball, I'm going to have a photon coming in, and then this photon is going to fall through height h. Initial kinetic energy of this photon will be HF, final will be HF prime. Initial potential energy is MGH, final is 0. So following our same pattern, can I write kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final? Kinetic energy initial is HF, potential energy initial is MGH, equal kinetic energy is HF prime plus 0. This is the photon mass. What did we say the photon mass was? HF over C squared. Okay, may I replace that in here? So I will have HF plus HF over C squared GH equals HF prime, or HF 1 plus GH over C squared equal HF prime. So this is my final energy of photon. This is my initial energy of photon after falling through H. You see why I called it big H here? Because I don't want to get confused between H and H, Planck's constant. Now, how does this help us? This helps us in something called gravitational redshift. Anyone know about gravitational redshift?